Mm. My name is Yamato Hashi. I'm from New York, and I moved here when I was 2 years old. And since then, I've also lived in California. My hobbies include music, like playing the trumpet and violin, but I also love playing sports like basketball and volleyball. I applied to IUPS because it's a unique program that allows me to kind of cooperate with people from different backgrounds, even in Japan, uh, allowing me to kind of maintain a similar environment that I've been experiencing in the United States. And I think this type of environment is extremely beneficial for my learning since from my experiences in the United States, I know how much you can learn from people of different cultures and different backgrounds.
Why do you choose the physics?
I chose to study physics because it was the most interesting science that I've taken in high school. It was very different from the other sciences I've taken, such as chemistry or biology, given that it used a lot of mathematics. And I find it intriguing that physics is able to logically manipulate equations and numbers in order to kind of predict the future and as well as explain the universe and its complex phenomena in a relatively simple manner.
What area of physics interests you most?
The area of physics that interests me the most is having to do with the sound waves and the physics and properties of sound waves because I am very interested in music. I love playing music and listening to music as I play the trumpet and violin. And I also listen to both Japanese and English music. So that's a big reason why that area of physics interests me the most. Another reason is because I think that we can use the physics of sound and sound vibrations in order to kind of create a new source of renewable energy by converting the vibrations into electrical energy. And I would like to kind of explore more on that topic.
Um, what experiment you had in high school was most interested for you?
The experiment that was most interesting was likely about centripetal force that I've I've done a couple of months ago in my physics class. This experiment was basically one in which we put a Lego figure inside a container that we made that we made to spin, and the centripetal force kind of pushed the Lego figure up across the wall, allowing us to visualize and better observe the centripetal force in action.
How would you reduce the measurement error in an experiment?
In an experiment, you could reduce error by just simply running the trial multiple times and taking the average, or you can completely make a different experiment that is less susceptible to human error or other sources of error.
Did you have the actual experiments or experience that you had an error, and how did you fix it?
Yes, for many of our labs, we experienced a high percent error from the accepted value, and we needed to, at those times, we needed to kind of go back to our data set, our data table, and see if there were any outliers or values that were kind of causing the large margin of error. And looking at those potential causes, we then looked for solutions to kind of alleviate or get rid of that error that we were making.
Um, what is the difference between the precision and accuracy?
The difference of the two lies in the fact that precision is the consistency or how many times you can get similar results, while accuracy is how close you can get those results to be to the accepted value. So precision is more of consistency and accuracy is more related to correctness in a way.
Thank you. Please explain physics concept you find fascinating.
A physics concept I find fascinating is related to the quantum field theory and the string theory. Both are theories that are studied by the Nishioka group that I mentioned in my essay. And these theories are the closest that we've gotten to a theory of everything. And the limiting factor is that those theories still are not able to kind of account for gravity and connect it to the three other forces. And this is interesting to me because the better we understand these, I guess, quantum level or these advanced physics, the more we could understand the world, of course, but also make advancements and benefit our human species. For example, better understanding the properties that lie in the quantum world will allow us to build quantum computers and advance on those, which would greatly speed up the, I guess, calculations that we can make.
Please share with us now whatever you know about the Mr. Nishioka.
Can you repeat that again?
Um, please share with us whatever you know about Professor Mr. Nishioka that you mentioned.
Well, I know that he runs the research group for the theoretical physics. So physics that kind of, I guess, tries to get closer to the theory of everything. Uh, TA, I know that he researches on the quantum field theory as well as the string theory. The quantum field theory being experimentally proven in many cases, while the string theory is only hypothetical. But understanding those theories better would allow us to kind of advance and push the frontiers of the physics world.
Okay. If you can join in Mr. Nishioka's group, what kind of research would you like to do?
Well, before I get started on any research, I would like to expand my knowledge base on the string theory and the quantum field theory themselves. Because although I talk as if I'm an expert, in reality, I only have superficial knowledge or surface level knowledge on these theories. And I guess I would like to learn more about these theories and expand my knowledge base on these theories so I could potentially contribute later on to the greater advancements in physics.
Do you want to pursue graduate studies?
Yes, that is one reason I would like to pursue graduate studies in order to have more time to expand my knowledge base on theories because the high school level of physics is nowhere near the the I guess the physics that is useful at the frontier of discovery. So I would like to expand my knowledge base and be able to later on contribute to the world, which is why I want to build up those skills with a graduate school and research.
Okay. What what topic? That would be the same question, but what the topic or the kind of the research that do you want to do? Do you want to study in college or the graduate studies?
Once again,
Mm,
I think I would like to study the and pursue research on the string theory and, well, mainly the string theory, I guess, because it's still a hypothetical kind of theory in which we haven't experimentally proven yet. Given that there's 6 or 7 more dimensions that it brings light to, maybe the string theory is not the correct theory, but learning more and researching more about it will definitely allow us as humans to step closer to better understanding the world.
okay. What would you like to do after graduate studies?
After graduate studies, I would like to maybe work as a professor in a school in order to be able to continue my research. I would like to continue my research so I have ample time to contribute to the frontier of discovery, make discoveries that benefit the world, like the quantum computers, and hopefully that experience or that knowledge that I've gained would allow me to kind of contribute to that advancement.
Uh, what do you think that what would be the advantage that to continue to research rather than to work for the general companies?
I think the main difference or the main benefit is that continuing to research would give me more freedom in a way and more time to research and study deeply about the theoretical aspects of physics because at the end of the day, working for commercial companies is based will have me tied and dependent to profit, which doesn't always coincide and it doesn't always relate to simply expanding the knowledge base or pushing the frontiers of physics just to simply understand the world better.
And commercial company may have their larger budget rather than the our university. How would you respond to when you have the limited budget or resource?
When I have limited resources, I think that I would simply cut down on the experimentation and work solely on hypothetical situations or theorizing about the phenomena and the different theories rather than physically testing them out, which would take up the resources.
Okay. Um, have you ever had failure in the lab? How did you respond?
Yes, many times I've gotten a high percent error in the labs conducted at my school. During those times, we just had to look back at our data tables, our data sets, and look for outliers of things we might have kind of did wrong or human error that popped up and find a way to resolve those errors for a better solution.
Um, can you give us an example that you faced a challenge in a lab?
One example would be with it's very frequent. So to give a specific example would be, I guess, ordinary, but for example, messing up the measurements for electric fields, just simply reading off the measurements wrong, or maybe the plus and minus clips were inverted. During those times, we just had to look back at the data set and find the point on the graph that was causing the incorrect data, I guess.
Okay, thank you. Let us ask some questions about your background. About uh, how did living in the United States for 15 years shape you?
Living in the United States shaped me to view the world from more different perspectives, as I learned a lot from different people of diverse backgrounds. For example, I learned about Ramadan in Islamic culture to kosher foods in Judaism, and learning about those not only expanded my knowledge on the world and cultures, but it also taught me that there's a lot more to the world and more prominent problems that need to be solved in the world based on where you're from. So I think this would allow me to better look at the contemporary problems in our society and in our world and be better fit to determine which problems need, I guess, the greatest contributions or the greatest work on.
Um, what do you s- what differences do you see between the United States and Japanese education?
The biggest difference I see is between in between US education and Japanese education is that in US education you're able to kind of choose your own schedule while also taking more advanced classes. In my school, many AP classes were offered, allowing students to take more take college level classes and courses even in high school. And this allowed curious students to fulfill their, I guess, learning hungers. And I think this was a good and beneficial opportunity for me as well to learn in a rigorous environment.
Um, why do you want to study in Japan now?
I want to study in Japan because I feel like I could contribute more there than in America. The biggest reason being that I have the experience of growing up in the United States. In Japan, I feel that the language barrier and also the lack of connection to the outside world kind of limits the reaches of the country's kind of advancements or discoveries. And using my experiences in both as a strong English speaker, but also one that has a background in Japan and knows Japanese, I think I could contribute greatly in being the communicator or the transfer of information and discoveries between Japan and the outside world.
Um, what can you contribute to the international classroom?
I can contribute my unique perspectives as a Japanese person who grew up in the United States. And as I've said, uh, there's a lot you can learn from the diverse perspectives of people from different backgrounds. And I think I could contribute I guess, my experiences with growing up in America to the international classroom.
How will you adapt to study in Japanese?
I don't necessarily need to adapt as much as maybe other people from other countries because I've studied and attended Japanese Saturday school since I came here from Japan. And in the Japanese school, we learned basically the Japanese curriculum. And therefore, I feel that I'm quite prepared and strong enough in Japanese education.
Okay. What is your biggest, strongest?
My biggest strength would be my hard work. The reason being that uh, I I work hard to achieve my goals from knowing that working hard could definitely working hard never betrays your ambitions. For example, when I tried out for the volleyball team in the United States in high school, I didn't make the team for 3 years, but each time I kept trying, working hard, working my legs in hot weather and walking to the nearby school to practice my passing skills on the walls. And this experience of hard work kind of taught me that in the end, hard work pays off. And yes, this was proven to me as I was able to earn a spot on the team the last year in my fourth year of high school.
Um, okay. On the other hand, what would be the opportunity that you think you can more improve?
The area I could most more improve on is likely my stubbornness. I often don't like to admit my mistakes as openly as I should be. For example, in many times in physics, when I make a mistake in calculations and I get into an argument with my classmate, I tend to close myself out from what they have to say and their method in approaching the said problem that we're working on. But recently, I've been trying to improve this and put myself in other people's shoe to view myself from third person and see that there's a lot more to learn even when you make a mistake.
Um, thank you. What recent scientific news interests you?
A recent scientific news that interested me was about the use of AI in theoretical physics. The article was about a student who was called over to OpenAI or ChatGPT's company in order to test out the new version of ChatGPT. And this physics student who was struggling with a problem asked the asked the new version of ChatGPT to help. And ChatGPT was able to solve that problem that the physics student was having in a mere 12 minutes or so. And the reason being that to solve theories or to solve problems that are as advanced as college theoretical physics, you need to use theorems and laws that are established beforehand. And there's no way that it's very difficult for the human minds to keep track of all the theorems and laws that have been developed across the world. But ChatGPT, since it has its huge capacity of memory and database, it was able to easily use a theorem from a 1950 research paper from a completely different country. But ChatGPT was able to use that theorem to solve the problem that the physics student was having.
What do you think that how AI will affect in the physics world?
In the physics world, I think AI would become a very useful tool, given that our human minds are not as capable or efficient in memorizing all the different theorems and laws that have been developed throughout the world and throughout the years. So I think AI would be a very useful tool, except for the fact that now we as humans need to know how to apply AI and when to use AI because at the end of the day, we are the ones who are putting in the input for AI and kind of guiding its output and what it would be solving.
Thank you. The interview is all. Do you have any questions for us?
One question I have is how I can better prepare myself before entering the, I guess, rigorous learning environment of college physics.
うん。OK。じゃあ、一旦ここまでにしようか。
Mm.
うん。